Today we're talking about systems of equations. And so first of all, we have to talk about what a system is, all right? So I'm going to give you an example of a system. Now, every system is represented by these brackets. I call it like a sideways mustache, right? But these brackets right here. So when you see this, this is indication of a system. So this part, the system. So these little brackets indicate that you're having a system. So let's give you this one. X plus y equals 4 and x minus y equals 2. This is a very, very, very basic system, all right? And a system is nothing more than two or more equations that are solved together at the same time, all right? So we could have systems that are 3 by 3 equations, 4 equations, 5, 10, really big, intricate systems here. This one's a basic one. It has two equations, all right? And so the idea here is to solve this system using a method called substitution. There are many methods to solving systems, and we're going to talk about all of them in Chapter 6. But for today, our focus is only on substitution, okay? So the way that this works is what you want to do is you want to solve one equation for one of the variables. So does anybody see an easy way to solve for one of the equations for one of the variables? Yeah, what do you see?
Add them together.
Nah, we could do that. That's called the elimination. We're going to get there next week. Yes, sir. What do you see?
You probably want to isolate y as a product or a term, meaning like y equals 4, and then you move the x over to isolate the y, so y equals 4 minus.
There you go. So let's take the first equation and say y equals 4 minus x. So I drew a little arrow and said y equals 4 minus x. So what I always do is I put a box around what y equals. Okay? Then I'm going to place it right there in the other equation for y. Does that make sense? So this is the substitution part, right? I am replacing that negative y in my second equation with a 4 minus x because that's what y equals. So here's what you end up with. You end up with, writing my second equation down, x minus 4 minus x equals 2. Now, why did I put that in brackets? Megan, what do you think?
Because that is, wait, actually, no,
Okay, what do you think, Steven?
Because when you put that into y, you pretty much distribute.
Yeah, he said make sure you distribute the minus sign. So you end up with this. You get x minus 4 plus x equals 2. Right? And this is now we're back in algebra land. Very, very easy. So this is 2x minus 4 equals 2. So that means that 2x is equal to 6. So x must be equal to what?
3.
All right, good. X must be equal to 3. Once I know that x is equal to 3, I can resubstitute it, check it out, right back there. Because after all, y just equals 4 minus whatever x is, okay? So I'll make this a little smaller, push it over. So that must be the case then that y must be equal to 4 minus 3. 4 minus 3, so y must be equal to 1. So therefore, ladies and gentlemen, these little triangles, these little 3 dots in a triangle, means therefore. So therefore, the solution to my system is a point. Check it out, 3, 1. So the answer is a point, 3, 1. So what does that mean? What does 3, 1 actually mean? Yeah, what do you think? Yeah.
If you graph them, then the graphs intersect at 3, 1.
Okay, so we're going to get to that point. But what else does it mean? It means something more than that. Huh?
It's the x and y.
Yeah, it is an x, y. But notice it's only one x and y. What does it mean, though?
The point.
Yeah, that point. Yes, what do you think?
It's a solution.
It is a solution. Okay, so here's what I'm getting at. This point is the only point that makes both the first equation and the second equation true at the same time. Okay? So watch it. Let's check it and see. If I plug in 3, 1, if I add 3 and 1, do I get 4?
Yeah.
Yep. If I go 3 minus 1, do I get 2? Yes, I do. Okay, so here's what we're going to do. You already touched on the point, but we're going to graph this right now. So let's bring the calculator into it so we can see both the algebra and all the work that we've done on the graphing calculator. I'm going to show you how to do this, okay? So on these graphing calculators, notice that you can only plug in a y equals. So that means that we have to solve each of these in terms of y. We did the first one already. We said y equals 4 minus x. So I'm going to plug that in. 4 minus x. That's easy. But I need to solve the second equation for y. What would I get if I solved the second equation for y? Steven, what would I get?
If you moved y to the right side,
Yep.
if you move 2 to the other
Yep.
side, you would get y equals x minus 2.
X minus 2. He's absolutely right. Let's go y equals x minus 2. Jenny, follow along? Very good. All right, so now that I have these two equations into my calculator, everyone to hit zoom and then 6. Everybody hit zoom 6, okay? Hold your calculator up to the screen. Make sure it looks exactly like mine. Take a little selfie with your calculator, all right? So take a look. Mine should look exactly like yours. Is this true? Mm-hmm. All right, good. So as we see, yep, those lines intersect somewhere, all right? They intersect at a certain point. So I'm going to teach you two new things on this calculator, okay? One, it would be nice to sort of zoom into this box, don't you think? Yeah. Okay, so here's what we're going to do. We're going to hit zoom. And notice the very first option is zoom box. So push enter one time, and you should see a blinking dot in the center of your screen. Do you see that blinking dot? Yep. Okay, so I want you to think of that as like a cursor on a screen. So you can move it around by pushing left, right, up, down. So if I go over right about here, so see where mine is? So put yours where mine is, and notice I have a blinking crosshairs. I want you to push enter one time, and notice it turns into a blinking box. Now what you can do is you can move your cursor left and right, up and down, and we want to zoom in on this spot. So I'm going to go down, and then I'm going to go to the right. So check it out. I'm creating like a little window here. Do you see that window I've made? Yeah. And I want to focus on where these two lines intersect. So after you have your box, if you push enter, you get a new screen, only zoomed into whatever that box is. Is that pretty cool? Mm-hmm. So you can now zoom in on points wherever you want. Without changing your window, you just hit zoom box. Okay, now we have this point here. We want to know what is that intersecting point. We have the inclination that it's the point 3, 1. So here's what we're going to do. We're going to hit second calculate, which is the second trace option. And which of those options there looks interesting to you?
5.
Okay, so just pushing the number 5, we'll highlight that one and bring it up. So right now your calculator is asking you for the first curve. Notice if you move left or right, it will stay on one of those curves. Curves in this case are the lines. So once I'm on this curve, I hit enter. And then notice it jumps to the second curve automatically, right? So then I can hit enter again. And then the calculator says, do you want to guess where they meet? Just say, no thanks, or just tell me what they meet. And check it out. Boom, they intersect at 3, 1. All right? So I want you to realize the algebra that we are doing, okay, corresponds to a coordinate point. And that coordinate point is the point that satisfies both of the equations being true simultaneously. And then I also want you to be able to graphically solve using your calculator. So you have a lot of skills going on here in this one little problem. Does this make sense so far? Everybody cool? So how many points are on this first line? Infinite. How many points on the second line? Infinite. So what's so important about this one right here?
It's the point where both ones balance.
It's the only one they share. It's the solution. It's the only one they share. So here's the system of equations. These are linear. X minus 4y is negative 11. X plus 3y is 3. I want you to solve it algebraically and then check your solution graphically using your graphing calculator. All right, was there anybody in the room who did not get negative 3, 2 for the solution to that system? Okay, so that's the one point they share in common. Okay, awesome. All right, so the title of this section is Linear and Nonlinear Systems, okay? The first two examples were examples of linear systems. Now we're going to get into something that's not so linear. And how do we know that this system is nonlinear? Yeah, what do you see, Paige? Yeah, the one on top there is a quadratic, okay? We can still use the substitution method, no problem. We're going to use the exact same thing, except we're going to have two answers here because of our quadratic. So I think I'm going to work with the second equation. That one looks easier for me to work with. So I'm going to get that y is equal to 2x and then plus 1. Is that true? Yes. 2x plus 1? Good. So I'm going to put a box around that, and then I'm going to substitute it right there for what y equals. Everybody on board with that part? All right, good. So here's what I have. When I rewrite my first equation, I get this. 3x squared plus 4x minus, in brackets, 2x plus 1 equals 7. It's very important that we put that part in brackets because I do not want you guys to not distribute that minus sign. Okay? Everybody cool with what I've done so far? Okay, I'm going to move this up so I have some more room to work with. So that means I'm going to have this. We're going to do 3x squared plus 4x minus 2x minus 1 equals 7. Yeah? This is definitely a quadratic. So how about 3x squared plus 2x? If I subtract the 7, I get minus 8 equals 0. Right? Now we definitely have a quadratic. Can we factor this?
Yes.
We sure can.
I got.
Wait, I want to factor it.
All right, go ahead and try and factor that. So it factors like this. It should be 3x minus 4 and an x plus 2. You guys get it right?
Yeah.
All right, 3x minus 4x plus 2. So we use the zero product property. So that means that 3x minus 4 is 0 or x plus 2 is 0. Doing some algebra, x is either a positive 4/3 or x is a negative 2. So ladies and gentlemen, we have two solutions here. Two x-intercepts, two x values. We need to solve each of those in for our y. Now, if you remember, I'll make this a little smaller. Our y value is here, 2x minus 1. So if I take the 4/3 and I plug in, I'm going to get y is equal to 2 times 4/3 and then plus 1. So that means y is going to be 8/3 plus 3/3, which is 11/3. So therefore, one of my solutions is if I plug in a 4/3, I'll get out 11/3. That's one of them. I have another one though. I have a negative 2. So if I plug that one in, I get this. Y equals 2 times negative 2 plus a 1. So that looks like negative 4 plus a 1. So that looks like a negative 3. So the other one I have is negative 2 comma negative 3. And this represents my solution set. Right? I have two answers here.
It's like, there's two, because it's like.
Exactly, there's two. So we're going to verify this algebraically, but before we can, okay, we need to solve this top equation for y. We already got that one for y. We need to solve the top one for y. So let's see here. I have 3x squared plus 4x minus y equals 7. So how about 3x squared plus 4x? How about minus 7 equals y? Is that true? Okay, so now I have two equations for y. I have this one and I have this one. So we're going to plug both of those into our calculator right now. I'll move this over so we can see it. So we'll go y equals, plug in, clear everything out, put that top one in. So 3x squared plus a 4x minus a 7. That's one of them. And the other one was just 2x plus 1. 2x and then plus 1.
And then zoom 6.
Yeah, and then zoom 6, so we're all looking at the same picture. All right, check that out. So does your graphing calculator look like my graphing calculator? Yeah, it sure should, right? So we have a linear line, right? We have a line here and we have a quadratic. And notice there are two places where they intersect. And we are saying that those two places are, let me move this up. We're saying that those two places are 4/3, 11/3, and negative 2, negative 3. So again, let's practice this. Everybody, let's go second trace. Everybody, second trace. You can just push number 5, and it will bring you back to the screen. So notice I have 2 points here. So I'm going to go closer to the left-hand point and push enter. And then it'll automatically jump to my line and push enter again. And check it out, I get negative 2, negative 3. That's good news. That's one of the solutions we got algebraically. Then I want to check the other point. So we start this over. Second calculate 5. Go over to closer to my other point, intersection. Push enter once, enter twice. Guess, no thanks, just tell me. Check it out. 1.33, well, that's 4/3, comma 3.6, well, that's 11/3. So that point represents our fractions here. So I want you to connect the algebra with the graph and realize that sometimes there are two solutions for systems of equations. In keeping with our systems, right, we've seen an example of one solution, meaning there's one intersecting point on the graph. Two solutions, meaning there's two intersecting points on the graph. And this one is going to be an example of no real solution. So we would expect to see that there's no points that they intersect on the graph. So that's what we're going to investigate right now. So notice it's a nonlinear system. One's a line, one's a quadratic. Okay. So I'm going to solve this one for y. Turns out y is equal to what? Is that x plus 4? Pretty easy, right? Good. I take all that information, I plug it right in there for y. So rewriting, I get this. I get x squared plus an x plus a 4 is equal to 3. So that means that x squared plus x, let's see here, if I subtract this, I get plus 1, right? Equals 0, yeah. So what do we have, guys?
Quadratic.
We have a quadratic. Very good. I can't factor that, can I?
Nope.
Nope. But I can use the quadratic formula. So A is 1, B is 1, and C is...
Oh, I don't like one.
You love this. This is their favorite thing ever.
That's not true.
Okay?
This one's easy.
This one's very easy, of course. So we're going to check the discriminant, checking b squared minus 4ac. We do that part first. So that means I got 1 squared minus 4 times 1 times 1. That's 1 minus 4. That's a negative 3. Ladies and gentlemen, negative 3. My discriminant is negative. What does that mean?
No real solution.
That means we have no real solution. That means we have an imaginary solution. So therefore, we have no intersection. So what that means, you guys, is that there are no points on the graph at which these two individual equations share. So the system has no solution.
No, that's not that hard.
Of course it's not that hard, right? So there's the entire problem right there. And we're gonna check out what we see here. In fact, I think I have this one right over here for you guys on fluid math. Okay, so here it is. Here's negative x plus y equals 4, and here's x squared plus y equals 3. So check this out. This is the actual equation, or the graph of the system. One's a line, one's a quadratic. And what are you noticing, you guys?
No.
They share no points in common. So therefore, this has no solution, okay? That's the reason why this has no intersection points, no solution. And I want you to realize that the algebra supports the graph. The algebra of having a non-real solution, an imaginary number, supports what you see in the graph by making the connection that there's no intersecting points. You guys cool with that?